Alright guys, welcome back. So in the previous video we talked about HNMR and we did an HNMR example right here, right, of how we make the structure given the HNMR. So before I actually go on to an example showing HNMR and CNMR together, I'm going to just go through this problem really quickly. It is a good practice. So let's just go through this one. It's asking you again to draw a structure based on the following spectral data from the HNMR. They tell you that we have a doublet, a singlet, and a septet. And they also give you the formula is C5H10 and 1 oxygen. So first thing always is to do IHD, right? So if you again forgot what the IHD is, make sure you put it on your index card. It's going to be 2C plus 2 plus the amount of nitrogens minus the hydrogens minus the halogen over 2. So now what we're going to do is plug everything in. You can get 2 times 5, that's 10, plus 2, that's 12, minus the amount of hydrogens, 10, minus 0 for the halogens, 0 for the nitrogens, over 2, that's 1. So we're going to have a double bond or a ring, right? Now again, when you have an oxygen, it's a very safe bet to draw a carbonyl. That is your 1 IHD. That counts as the double bond. So we're going to build it based off of that. Okay? And so let's get started. So we have a doublet, a singlet, and a septet. So let's go look at the singlet first. That's usually the one that's, it wouldn't usually be the one that's easiest, but it is sometimes. So a singlet, remember, if that's how it looks on the HNMR, remember that n plus 1 tells us what our peak is going to look like on HNMR, right? So we have the singlet, which means that we're going to have 1. Subtract 1, n equals 0. That means whatever the hydrogens we're looking at that gave us the singlet, it has no adjacent hydrogens, okay? Now, how about the doublet? Okay, so actually, let's write it here. So, no adjacent hydrogens. Let's look at the doublet. Remember that n plus 1 equals doublet, which is 2, subtract 1, n equals 1. So whatever the hydrogens we're looking at that's giving us our doublet, the hydrogen we're focusing on, has 1 hydrogen that's next to it. Let's be careful. 1 adjacent hydrogen. Okay? Now, this septet, sept means 7. So n plus 1 equals 7. Subtract 1, n equals 6. 6 adjacent hydrogens. Okay? So we have singlet with no adjacent hydrogens, doublet 1 adjacent hydrogen, septet is 6 adjacent hydrogens. Here's our carbonyl. We're going to base it off of this, right? It's going to help us build it. So, to make off of a carbonyl, to make a singlet, right? So something with no adjacent hydrogens, all I have to do is I have to draw a methyl. Because look at it. I can look at any one of the hydrogens on that methyl, right? Remember, they're all considered the same. So we treat them as 1. Next to it, the only carbon next to it is this one. There are no hydrogens on that carbon. So n plus 1, 0 for the no adjacent hydrogens, plus 1 equals 1. That's our singlet. So we're going to get that methyl there. Okay? Now, we have to take care of the doublet and the septet. Now, the only thing you can really do, obviously, using this carbonyl, is we have to draw the carbon somehow, right? So here we go, because we can't touch that methyl. That's correct. So we draw a carbon because we can't really do anything else, right? And the formula uses 5 carbons. So we have, so far, 3. We're missing 2. Now, you've seen this pattern before. You have this septet, right? So 6 adjacent hydrogens. And a doublet, remember, which means that, and the doublet means it only has 1 adjacent hydrogen. That's going to be very similar to this isopropyl group. Here we have CH3, CH3. there's this one hydrogen on this carbon, and all the hydrogens of these methyls are the same. So I'll just color them all the same. So let's look at the blue hydrogen first. It has 6 adjacent hydrogens. 6 plus 1 is 7. There's our septet. Now, the hydrogens, on the red hydrogens, remember, these are all the same. So we treat them as 1. That's going to be 6. So that's going to be all 1 hydrogen that we're going to treat it. And it has 1 adjacent hydrogen, which is that blue one. 1 for the blue, plus 1 to account for what we're looking at as our hydrogen of interest, right? Which is one of these, or one of anything from there, is 2. That's your doublet. So our answer is just going to be this ketone. Okay? So that's how we do that. And so that wasn't too bad of an example. Now we're going to go on to this HNMR and CNMR together. Okay? Not as bad as you guys may think. All right, we're going to take it one step at a time. So the top part is the CNMR, bottom part is the HNMR. They gave us a formula, C8H10, and they also told us something very interesting. The total integration of the peaks around 7 ppm. Oh, I'm sorry, this is actually the HNMR. I don't know why I said that's the CNMR. The bottom is the CNMR. So they told us the peaks at around 7 ppm, which is that one right here, has an integration of 4. That means that peak represents 4 hydrogens. And the integration of the peak at around 2 ppm is going to be 6. So 6, 4. All right, so that's a big hint. So always first step when you're doing HNMR, CNMR, IHD, always. Okay, so I'm not going to run through the formula here. I'm just going to get right into plugging it in. So you're going to see that we're going to have 8 carbons, right? We're not going to have, there's going to be plus 2. We're not going to have any nitrogen, so plus 0, minus 10 hydrogens, 0 halogens, over 2. That's going to give us an IHD of 4. Okay? This is another massive hint to solving this question. You have an IHD of 4. Most of the time, that is representing a benzene ring. So here's what we're going to do. We're going to start off drawing a benzene ring. Okay? So before we even go on and look at the HNMR any further, we're going to look at the CNMR. All right? That's going to tell us how many unique carbons we have. So we have 4 CNMR peaks. So we have to have 4 unique carbons. Yet we have 8, so we're going to have a lot of symmetry. Okay? So 4 unique carbons, but 8 total, some symmetry going to happen here. Okay? So keep that in the back of your head. Now, what I want to do is I want to look at the benzene peak right here. Remember that between 7.5 to 8.5, right? That's going to be your benzene peaks, the hydrogen on a benzene. The integration is telling you that we have 4 hydrogens represented by this peak. Now you can see that it's almost impossible to tell what that peak is. So that's the thing about benzene peaks. Oftentimes they're a little bit strange. If you try to count your benzene peaks, you're going to have a very tough time. So a lot of times you don't even have to worry about that. 4 hydrogens for your benzene peak. That means that on our benzene, we need to have 4 hydrogens. As is, the benzene has 6. I draw it 1, 2, 3, 4, 5, 6. There are 6 peaks on our benzene, 6 hydrogens on our benzene, right? So the integration is telling us how many hydrogens that peak represents, right? Because remember, HNMR doesn't pick up the peaks that are the same as each other. It doesn't pick up the hydrogens that are the same. So that's the purpose of the integration. So we can't have our benzene looking like this. You can't have all 6 hydrogens. And we also knew that based on the formula, we still didn't account for 2 hydrogens. 2 carbons, right? So we're going to have to add substituents somewhere. Now, how do we know what our substituents are going to look like? So let's see. Let's say I drew our two hydrogens this way. I am going to have one hydrogen here, 2, 3, 4, 5, and there's none here now. That's an integration of 5 would have been our benzene integration. In that peak right here, the 7 peak, we would have had a 5H. They told us our integration is 4. So that means that those two carbons have to both be separately on the benzene. Now, how is going to be the question, like what's the pattern? So that means like we could have drawn it something like this. This way, this way, or this way, right? Those are the only 3 combinations, right? If I picked this and put it here, that's the same exact thing because it's symmetrical. So out of these 3 combinations, which one is going to be the right way of doing this, right? So to figure this part out, we're going to now need to use the CNMR, right? According to our CNMR, we have 4 peaks. That means 4 unique carbons, right? CNMR is carbon-centered. So it's going to be based around our 4 unique carbons. So what we're going to do is just draw lines of symmetry and seeing how many unique carbons we have. You can cut this down the middle. That's one cut. But don't forget, you can also cut this in half. It's symmetrical 2 ways. So we're going to look at one quadrant. So how many unique carbons do we have here? 1, 2, 3. That's 3. That's not 4. If that was our answer, we would have gotten 3 signals on our CNMR. Now let's look at the bottom one over here. We can split this in half this way. 1, 2, 3, 4, 5. Don't forget about that one. That's 5. That's going to give us 5 signals on our CNMR if that was the answer. If we do this one, now we're going to do 1, 2, 3, 4. 4 signals. Perfectly matches up with our 4 CNMR signals. So that means that this structure right here, let's change the color. This one right here, that's going to be your answer for this. So you guys see we went through an entire example of using both CNMR and HNMR. We talked about integration in this one, that was given, and IHD. So this is a very good question, and something like this could very well come up on your test. So be prepared. All right. I hope this video helped you guys on HNMR, and you guys had your workshop quizzes. If you're still a little bit confused, feel free to email me, comment if you're watching this on YouTube. Go to the CLC. Your test is Monday. All right. And I will see you guys in the next video. Good luck on your exam.